Okay, this is for pages 9 through 12 on chapter 14. How to simplify a rational expression when you have polynomials on both top and bottom. And the key way to do that is just you got to factor. You try GCF first, and if not, you have to factor using two brackets. So look at this question here. Take a quick peek at this right there. Yeah, let's do this. There we go. That's better. Real simple. On the bottom of my fraction, I'm going to factor that separately and factor that separately. Well, x squared minus 4 does not have a GCF, so I have to use two brackets automatically. You break apart the first term, x squared, and of course, into x and x. The first sign is negative, so it goes in the first bracket, but the last sign is also the sign, which is negative, which means to use a different sign than the one you put in the first bracket, which would make it a plus. Reading backward, what are the factors of 4 that have a difference of nothing? Basically, what's the same factor times itself that gives you 4, which would be 2 and 2. Okay. On the bottom, this does have a GCF of 4, which is always one bracket. Taking 4 as a factor out of 4x leaves you with x. Taking a 4 out of a factor of negative 8 leaves you with negative 2. So once you've broken it down to this, really simply, you have to start to locate what your undefined values are before you can go forward to your final answer. So if I put 4 equal to 0, it would cross out, it would make no sense, so you would have to just reject that answer. But here, x minus 2 said equal to 0, you would add 2 to both sides. X can't be worth positive 2. So with positive 2 here, 2 minus 2 would be 0. 0 times 4 leaves a bottom total value of 0, which is not allowed to have happen. Okay, once you got this here, here's how the difference is with binomials as opposed to monomials when you reduce your fractions. With monomials, if you had a 2 and a 4 up here, they can reduce to 1 and 2. They don't have to be an exact match. With binomials, the only way to get rid of x minus 2 down here is to find an exact match up there. So those cancel out, and what you're left with on top is x plus 2. Either in or out of the bracket makes no difference. On the bottom, you have 4. So your reduced fraction is x plus 2 over 4, just as long as x is not equal to 2. Look at the next one right there. This has a GCF of 4, leaving x plus 2 in the bracket. This has a GCF of 3, leaving x plus 2 in the bracket. Before I go to my final answer, let's find out where we're undefined. X can't be equal to negative 2 this time, because if I take x plus 2 equal to 0, I'd have to subtract 2 on both sides to get it there. I have an exact matching binomial in this case, so they cross out. And my fraction, believe it or not, is 4/3, just as long as x is not equal to negative 2. Now, I know that the final answer doesn't have an x in it, but it came from something that did have an x in the bottom. These things are equivalent to each other, but because this had x in the bottom to start with, I have to account for that. It can't be negative 2, and that's why it's part of my answer. Okay, last piece here, what if I have a trinomial? Well, nothing really changes too much. Basically, do you have a GCF or do you not have a GCF is how you go about it. On top, there's no GCF, so it's two brackets. X squared splits into x and x. The first sign is positive, so the first bracket gets a positive. The last sign is positive, means you keep the same thing that you had in the first bracket. Same. Keep this same sign into the other bracket, also it must be matching signs, so they're both pluses. Reading backwards, what are factors of 15 that add up to 8? 5 and 3, always put the larger value in the first bracket. On the bottom, this has a GCF of 2, which is only one bracket then. 2x divided by 2 is just x. 10 divided by 2 is 5. There's your preliminary answer. Before we find out, let's find out where x can't be. X plus 5 equal to 0. I would have to subtract 5 on both sides, so x can't be negative 5. If I cross out exact matching terms for my binomials, I get x plus 3, again, in or out of the bracket's fine, over 2. And that's how you simplify rational expressions when you've got polynomials all over the place.